Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's see how you did on your homework. For your M&Ms, you were just getting more information about the real number system, which I feel like we pretty much got most of that into your notes yesterday. Real numbers include all rational numbers, which are the numbers that can be written as either fractions with integers. That's what this P over Q represents. It's a fraction or a rational number. A fraction where the numerator and the denominator are integers, and then this little qualifier Q can't be equal to 0. So while the fraction can contain integers, you can't have 0 in the denominator because that's an undefined number. But other than that, you're allowed to have any integer in the numerator and any integer in the denominator. So 7 over 1, if you take the number 7, it is an example. While it looks like a whole number or a counting number, if you gave it a denominator of 1, which you're allowed to do with all fractions, it becomes a fraction with integers. So 7 is a rational number. If you take negative 0.687, its name is negative 687 thousandths. Integer in the numerator, integer in the denominator, that's a rational number. If you were to convert the square root of 25, what do you multiply times itself to give you 25 for an answer? It's 5, and since 5 can be written as 5 over 1, it is a rational number. So all of those are examples of rational numbers, whether or not they're in fraction form, in decimal form, or written as a radical expression that could be simplified into a fraction with integers in the numerator and denominator. Now we get to the irrational numbers, and something that you're going to notice is this. Most of the irrational numbers that we talk about are these types of radical expressions where the number inside the radical, which we call the radicand, is not a perfect square. If it's not a perfect square, then you're going to get something like this, where the decimal number just keeps going on and on and on forever with no clear pattern to it, no pattern at all that you can see. And so we're just going to have to round it off, which means that it's going to be an approximation. It's not going to be the exact answer. And then, of course, you've got some other things that show up as irrational numbers like pi. And there are a few others out there, but I'm not going to bother going into the details with them because we won't be working with any of those. We'll only work with pi and these square roots. All right, this problem right here requires you to understand the basics of Pythagorean theorem, but there is another formula that I'm going to show you that algebra teachers will teach you when you are measuring the distance on a coordinate grid. There is a formula that's a variation of the Pythagorean theorem. So your task was to graph each one of these points and then plot those points on a coordinate grid. Let me get rid of you. On a coordinate grid, and then figure out what is the physical distance between those points. So if you take negative 3, 0, and 0, negative 3, here they are, but it's kind of hard to tell. It's like this is 1 unit, this is 1 unit, but the distance from here to here is a hypotenuse of a right triangle, which is greater than 1. The question is how much greater than 1? What is it? So without being able to use a ruler, how are you supposed to figure out the distance from here to here? Well, luckily, we can create a right triangle on the coordinate grid because we've got all these vertical lines and all these horizontal lines that are, by definition, perpendicular to each other, which would form the legs of an imaginary right triangle. So if we can figure out the distance from here to here and the distance from here to here, then you've got your a squared and your b squared would be 9 and 9. Add those together to give you 18. So c squared has to be the square root of 18. And the square root of 18 is right around 4.2. So the distance from here we would call approximately 4.2 units. And that is an example of an irrational number. Since 18 is not a perfect square, you get this decimal number that goes on and on forever that we've rounded. Same thing here. You've got this point, negative 1, 2 here. This point here is 2, 3. So how many units is that? It's kind of hard to tell. But we can tell this is 1, 2, 3 units horizontally, and this is 1 unit vertically. So 1 squared plus 3 squared will equal whatever that is squared. So 1 plus 9 is 10, so the square root of 10 is about 3.2. That's an irrational number. This is the only example where we didn't have to create an imaginary right triangle, because we can measure the distance from 3, 2 to 3, negative 3. It's 1, 2, 3, 4, 5 units. So no trouble with that one at all. Let me show you the distance formula and show you how it's related to Pythagorean theorem. This is the distance formula. It says that the distance between any 2 points on a coordinate grid is equal to the square root of x2 minus x1, and which one of these is x2 and which one is x1, it doesn't make any difference. It's just this, we could call this x1 and y1, we could call this x2 and y2. So negative 3 minus 0, or is it 0 minus negative 3? It doesn't even matter which direction you go. But the difference between those two is going to be either 3 or negative 3, that when you square it becomes 9. Because negative 3 times negative 3 is equal to 9, and positive 3 times positive 3 is equal to 9. So it really doesn't make any difference whether it's the positive or negative. It's just the absolute value of that difference. And then 0 minus a negative 3 is going to give you a 9 there. So when you add them, you get 18. And sure enough, the distance is going to be the square root of 18, which we said was about 4.2. How does that relate to this? Well, if I were to just take square root of both sides, I can figure out the square root of c squared. It's c. And that's going to be equal to square root of a squared plus b squared, which is a more complicated. You can't just say that the square root of a squared plus b squared is a plus b. It doesn't work that way. You'll learn more about this at a later time, but that is not going to work. So you just leave it like this, and this ends up being the same as that if the distance is the hypotenuse, which is c, and the difference between these two gives you this distance here, which would be like a, and then you square it to make 9, and so on and so forth. So I am not testing you on the distance formula. We're not going to worry about that. We are simply going to focus on Pythagorean theorem. But it's good to introduce you to these concepts because you'll get more of it later in high school. Howie and Steve are making cookies. For themselves, the recipe they're using makes 48 cookies, but they only want to make 16. They have no trouble reducing the amount of flour and sugar, but the original recipe calls for this mixed number that looks horrible, 1 3/4 cups. So how are they going to figure out how much butter that they need? Well, if you think about this, to go from 48 to 16 has a scale factor of 1/3. So they would need 1/3. If they're going to make 1/3 the amount of cookies, they need 1/3 the amount of flour, 1/3 the amount of sugar, and 1/3 the amount of butter. So what is 1/3 of 1 3/4? Well, that is a multiplication problem. So when you take 1/3 of a number, you multiply it times that number, and I'm going to change that to, what does that become? 7/4. Nothing can simplify here or cross cancel, so we just multiply straight across, and you get 7 twelfths of cups of butter, and good luck measuring that using teaspoons or cups or whatever. Just throw in a stick. I'm sure that's going to be fine. All right, find the perimeter and area of the figure at the right, copy the figure onto your paper, and show your work. Okay, so do you see this missing part right there and this missing part right there? Well, I filled in the numbers, but you didn't have the numbers. You had to figure out that if this distance all the way across is 10, and they only show 6, and the rest of it must be 4. And if this distance across or up from bottom to top is 8, and they're only showing you 5, then the rest of it has to be 3. Well, what do you see right there? How are you going to figure out what this line is? Well, that's the hypotenuse of a right triangle. So a squared plus b squared equals c squared. What is 3 squared? That is 9 plus 4 squared, which is 16, equals whatever c squared is, which is 25. So that means that c, if c squared is 25, then c has to be the square root of 25, which is 5. So now that we know that, we can find the perimeter without too much trouble. 6 plus 5 is 16. 26 plus 8 is 34. Now, finding the area, that's a little bit trickier. So what we're going to do, I would recommend, rather than break this guy up into a rectangle and a trapezoid and finding their two areas and then adding them together, I'm going to choose to take the bigger area and then subtract away the area of this right triangle. So what is the area of the bigger? That would be a 8 by 10, would be 80 meters squared, correct? And what is the area of this triangle? Well, to find the area of a triangle, we take 1/2 times the base times the height, correct? I never write it like this. That's crazy. You take 1/2, that's a 2, times base times height. So base times height is 12, and what is half of 12? 6. So the area of this alone is 6, and that's what we're taking away from the 80. We take away 6 square meters from the 80 square meters, and that is how we get 74 square meters for this section of our drawing. All right, scientific notation. Identify the leading digit. That's a 3, so we're going to make this 3.7. And what place is the 3 in? That looks like the 100 millions place. 100 million has 1, 2, 3, 4, 5, 6, 7, 8 zeros. So instead of saying 3.7 times 100 million, we'll call it 3.7 times 10 to the 8th, since 10 to the 8th means 100 million. This one, a little bit harder to figure out. 7 is the leading non-zero digit, and then when you've got these powers of 10 that are less than 1, I just count the number of decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 12th decimal place, that's your answer right there. Simplify each of the following expressions. All right. We've got all those exponent rules from, I believe, chapter 8. And if you were to expand all of these guys out completely, I'm not going to do all of them, but I'll do a couple. This would be 4 times x times x times x times y times 3 times x times y times y. Let's take the number parts and put them together. 4 times 3 is 12, correct? And then we take all of our x's, 1, 2, 3. That's got to be x to the 4th. And then we take all of our y's. You got y times y squared is y to the 3rd. Okay, so just expand them out, count them all up together. We don't have any parentheses in here, so we didn't have to do any power of a product. But we do have, maybe I'll do this one right there. That looks kind of complicated too. I'm still going to do this one. If anyone wants me to do D, feel free to email me and I'll create something and I'll send it back to you. Okay, so I'm going to separate these guys out into 9 over 15, and then there's just an a to the 4th on the top. There's nothing there at the bottom, so I'm going to hold that place with a 1, and then b squared on the top over b. Okay, so 9 over 15, that's a fraction that can be simplified down to what? 3 over 5, I think. And then a to the 4th doesn't have anything to cancel out, so times a to the 4th, and then b squared divided by b to the 1st. Remember when you're dividing powers, how you keep the base and you subtract the exponents, so that becomes times b. So you could either write it like this, or knowing that these would have denominators, they can all go up in the numerator together. Okay, so once again, if you need me to work out any others of these, I'll be happy to do it. I would check the homework help online. They might actually show you some of the processes on there that will help clarify your thinking. And then absolute value expressions. Remember order of operations, PEMDAS. The very first thing you have to do is parentheses, but the parentheses aren't just parentheses, they're all grouping symbols. So the absolute value bars qualify as grouping symbols. So basically, like for this one, they're all inside there. So you're just going to simplify and then take the absolute value of that. Negative or 5 times minus 6 is -1, and -1 plus +1 is 0. So the absolute value of this expression is just 0. Here we must find the absolute value first. So we have to take -2 and we're multiplying it times the absolute value of negative 16. Remember, when you have a number next to parentheses, it means you're multiplying them if you don't see any sort of operation symbol in between there. Well, that's what we're doing here as well. So since I know that the absolute value of negative 16 is 16, I'm just going to replace the absolute value bars with parentheses and replace the negative 16 with positive 16. And that's how you get negative 32. And then here, the absolute value of 6 minus 2 is the absolute value of 4, which is 4. The absolute value of negative 8 minus 1 is the absolute value of negative 9. That's a common mistake. A lot of people think that's supposed to be negative 7. But remember, KFC, when you're taking a negative minus 1, that's the same as saying that negative plus a negative 1. And so it's really negative 8 plus a negative 1, so it's negative 9. The absolute value of negative 9 is 9, and that's eventually how you're going to get to your 13. I'll draw a box around all of them, and I think that's it for today. It is. All right, so on to part 2 of 9.4.4. Hope you did well on the homework. Talk to you in a little bit.
Hey, feeling good.